Hi there, everybody. We're going to do a series of short videos on some of the properties of modular arithmetic. This is primarily from section 8.2. So make sure I'm in here. So what we're going to look at, we're going to look at the question that's on the board in front of us. One of the first ones is solving a particular quadratic equation, particularly finding the solutions to the equation x times x plus 5 equals 0. So if you watched the last video, you might remember that like if we were in Algebra 1, piece of cake. We would just go ahead and use the zero product property, either x equals 0 or x plus 5 equals 0, done. And that's pretty straightforward. But as we saw in the last video, the zero product property does not actually work. Or at least we don't, it's not guaranteed that those are the only possible solutions that we might get. So what we're going to do instead is I've got my table up here again. You'll notice I've got some things highlighted in there. So before I get into that, I just mentioned that we're not going to do this algebraically. And that's not because it can't be done algebraically, but because some of the rules that we are familiar with don't apply in the same way when we're dealing with modular arithmetic, or at all. And so we don't want to go ahead, we don't want to like plunge forward algebraically assuming we've got all the rules down, because the rules are a little bit different. As we saw, some things are different, particularly with regards to multiplicative inverses. So we're going to do this numerically. So looking at the table again, you'll notice that I have a couple of things highlighted here. So you'll see that these are all highlighted down there. It might be a little light on your screen, but here they are as well. And what I did for each of these is basically I was looking for, the goal here is I have some number and then 5 more than that number. So what I'm looking at is I'm over here and I'm considering, okay, 0 is a number, 5 more than that number would be 5. So I'm looking at 0 times 5. Or if I look at 1, it would be 1 times 6, because 6 is 5 more than 1. 2 and 7, and then 3 and 8, and so on. And so you'll notice that it just keeps coming right down to here until it wraps around here, because one way you can think about modular arithmetic, it's kind of living on a circle. And in fact, you know, side note, when I first learned about modular arithmetic too many years ago to recount, it's actually on a circle that I was first introduced to it. So that's one way to think about it. Okay, so what we're going to do is we want to just look at, like, that gives us just what the possible products are as we're multiplying these together. So as I'm multiplying x and x plus 5 together, the things that I've shaded in are the possible solutions to that. Well, we obviously want to know, where is this going to be equal to 0? And so there's the obvious one, like clearly 0 times 5 is 0. So that makes sense that x, one of the values of x would be 0. And so that kind of makes sense in the process. The 7 times 0 may make a little bit less sense, but if you think about it, normally we would say in algebra, in normal algebra, x plus 5 would have given x equals -5 as a solution. But if you think about it, -5 mod 12 is actually 7. If you're not sure about that, think about how that would work. Basically, 5 before 12 would be 7, if we're going backwards around this kind of circle. So those two kind of make sense. The surprising ones, however, as we continue down, we'll notice that down here there's nothing else. But if I come up to the other row, I notice I get to 3 times 8. Well, 3 times 8 is 24. And that, yeah, that definitely is 0 mod 12, as is 4 times 9, which is 36. So we end up with 4 solutions here. We get 5 and 0. We get 7 and 0. We get 3 and 8. And I'm sorry, these aren't x. This is just what the pairs are. I should be writing this down. 4 and 9. The values of x, just so we're clear, are 5, 7, 3, and 4. Okay, so just think about that for a moment. Okay. Why aren't they the other ones? Well, that's a good question. If I let x, I'm sorry, and actually 5 is not one of them as well. That's 0, not 5. Sorry, my apologies. I put them in the wrong order. So here order kind of matters. Because if I let x equal 5, then I have 5 times 5 plus 5, which is 10. And if we look over here, 5 times 10 is 2. So that does not actually work. So it's important, so I should have put them in the right order. It's actually these 4 numbers that we're looking for as our solutions here. Okay. So it's just that these 4 combinations equal 0 in mod 12. Okay, but those are our 4 solutions. We'll take a look at a couple more questions in the next videos.